number, and it'll be the square root of negative 5b.
Hold on 1 second. Let me get this to where I can start writing.
Okay.
Go ahead. Now I can do it.
Square root of negative 5v plus 44, and then outside of the square root equals v minus 4.
We adding, subtracting, multiplying? What are we doing?
It says pretty much solve it and find if it's a real number.
It's equal to b minus 4?
Correct.
Do I have it written correctly?
V as in Victor, but B works too. Yeah, you have it written correctly.
Okay, so what's the first thing we're going to do here?
So first, what I'd like to do is get the plus 4 out of there, I believe.
No, not really. When you see a radical sign think of as like a denominator or a parentheses. That's what you want to get rid of first.
So I should square both sides.
Yes. Because I know what I'm going to get when I square the left side. I'm going to get this. Tell me what I get when we square the right side.
So it'd be v minus 4 squared, so I'd have to factor that out. 1 second.
You gotta foil it.
Yep, so that would be v squared minus 4v minus 4v and 16.
Plus 16, okay.
Yep.
Now we're looking at a quadratic. Because all we got to do is get everything on one side, set it the other side equal to 0, and we're good to go. Which side are we going to put everything on?
It looks like I'll put everything on the right side.
Okay. So tell me what
subtract 44. So it subtracts 44 and add 5b.
Start with the highest term polynomial. So that there's only going to be one b squared.
Okay.
Now move all the b's over. How many b's are we going to have?
Now we're going to have negative 3b.
And finally the number. How many numbers are we going to have?
And we'll have 60.
No, we got to subtract 44.
Oh, yeah. So 44 minus 16. That would be 28.
I think minus 28, yeah. Okay, I'm not using a calculator here, so I could make a mistake. But okay, now can we factor that?
Yes, I can.
Okay, into what?
So I would try. So I know the factors of 28 are 7 and 4.
Okay.
So I'd pick a negative 7 and a positive 4.
Good.
And then I have to equal that to 0.
So what are your two solutions for b?
7 and 4.
7 and negative 4.
Yeah, 7 and negative 4, since I have to switch it.
Now, see if that violates any domains. In other words, we got to be careful. That amount right there has got to be greater than or equal to 0.
True.
It is. It is with the 7 because we have minus 35 plus 44, so that's positive. And it is with the negative 4. That's also positive. So both of those solutions should work. Neither one of them violate a domain. And that's your only other consideration once you've solved it.
Okay. So I just put that in when it's equal to 0.
I'm not sure I understood the last question.
So to check it, I just factor the 7 in for b equal to 0.
Well, not equal to 0 into this.
Okay.
We could do it at that step, but not really. You really want to go back to the original equation, always. Particularly if you're dealing with something like logs. If you're dealing with logs, you can be violating a domain in the original equation and not violating it once you've turned it into a quadratic. So you got to be careful. So when you're checking how many of these solutions are extraneous or not, you got to go back to the original
Gotcha.
to check it. And you could check it by just, I mean, I've been dealing with this stuff enough that I know the only way these aren't going to work is if they violate a domain. I don't have to check it completely. If you notice that if we check it completely, we get the square root of 9. Is that equal to 7 minus 4? And yes, it is.
Mm-hmm.
Or if we plug in minus 4, we get the square root of 64. Is that equal to minus 8? Ooh, I just discovered something. Minus 4 does not work.
Yeah, -4 doesn't work.
No, it doesn't. Because the square root of 64 is not equal to minus 8. So that is an extraneous solution. So I was
Okay.
completely wrong. It's not all about seeing whether it violates domain. What you really need to do is check both solutions. You just
Gotcha.
check them and make sure that they are both valid.
Okay. So I got the next one.
Okay.
So this one is 4, then the absolute value of x minus 8, then plus 2, and all that is greater than 18.
Okay. Underlying principle here is tell me what this means.
So if I remember correctly, it makes like anything inside of it positive.
No, this has a very specific meaning. It means one of two things. The first thing that it means is everything you're looking at without the absolute value sign,
Mm-hmm.
or it means x change the direction of the inequality and change the sign on the term on the other side. So
Gotcha.
that's the two things that this thing means. Okay? Now, so if we apply that theory, and this is what you want to memorize, is how to do an inequality using absolute value. Well, what we have to isolate is that. So let's do that first. How do we get rid of the 2? How do we get rid of the 4?
Um, could I divide everything by 2?
Not divide.
Or divide everything
No.
by, or subtract 2?
First subtract 2.
Okay.
That turns that into 16. Now
And then I can divide by 4.
Now divide by 4. And now what you have is you've isolated the absolute value. And now you can apply the definition that I just told you. So what does this thing mean?
So I have to change the sign and
Well, that means one of two things. List both things. That's the first step. Just list what it means.
okay, so it would be -4 is greater than.
Hold on. The first thing it means is everything you're looking at, just take away the absolute value sign.
Okay.
That's the first thing it means. What's the second thing that it might mean?
X minus 8 is less than -4.
Yeah, never change what's inside the absolute value, but you do have to change two things. You got to change the direction of the inequality, and you got to change the sign on the other part. Now you have two inequalities that you can solve fairly easily. The one on the left solves how?
I would just add 8 to both sides. So it'd be x is greater than 12. And then the bottom one, I'll add 8, and that would be x is less than 4.
Correct. And those are your two answers. And if they ask you to graph it, we're going to graph it on a number line. There's 12. There's 4. And your solution all the way to infinity in that direction, or x is greater than 12, circle because it's greater than only. It's not greater than or equal to. If it was greater than or equal to, then these would be solid circles.
Okay. Gotcha.
Okay.
So then the next one I've got is, one second. Okay. So it shows like the fourth square root of 5v plus 6. And then outside of the square root is plus 2 equals 5.
Like that?
Yes.
Exactly like that?
Or the, what's its name? The 5v plus 6. I think, and then a plus 2 outside.
There's a plus 2 like that.
Yep, perfect.
Okay. It's the first thing we're going to do.
So for this, subtract the 2.
Okay. Always get rid of things that are being added or subtracted
Okay.
as a first step, if you can. Notice that we can do that real simply without affecting anything else. Now, what's the next step?
Get rid of the fourth root.
Okay, how do we do that?
So I guess put everything to the fourth power.
Yeah, that fourth root is the same as to the 1/4 power. So if I take everything to the fourth power, both sides, I'm left with whatever was inside that radical on the left. And 3 to the fourth is 81. Now it becomes trivial.
Yep, so then minus 6.
Mm-hmm.
And that will be 75 equals 5v. And then subtract or divide everything by 5. And then would it be 14?
I think it's 15.
15? Okay. So v equals 15.
Yeah.
And then would I have to put that in and then check it?
Well, you know, that's a difficult question to answer, Taylor.
Yeah, that'd be awkward since the fourth root.
Well, you don't have to worry too much about it on problems like this. So
Mm-hmm.
my answer would really be no. You shouldn't take the time to do it unless it's a test where time is not a factor. If time is a factor, then you have to measure that against, the chance that you've made a mistake. If time is not a factor, then I always check. Absolutely. Plug in v, you get what's the fourth root of 81? Fourth root of 81 is 3. So it works. But if time is a factor and you only have a limited amount of time to take your test, then no, I would never check a single answer. If you get
Okay.
2 answers, yes, every time we've seen 2 answers, one of them is extraneous.
Mm-hmm.
So always check when you have 2 answers. But when you only have one, I can't even ever remember finding one that didn't work if you only came up with one answer.
Okay. So the next one I got is calculate the distance between the points h equals 1 comma negative 6 and f equals 9 comma negative 9.
So calculate the distance between those 2 points.
Yep, so I'd say the distance formula, which would be y2 minus y, or actually no, would it be x2 minus x1?
First of all, it's the square root of.
Yep, the square root.
Why? Because that is always the hypotenuse of a triangle.
Gotcha.
And when you solve a right triangle, the answer is always starts with square root of. And now you have your x2 minus x1 squared. In other words, this side
Then the
plus
y2 minus y1 squared.
y2 minus y1 squared. And notice that we can do this in any order. I could do x1 minus x2. I'm squaring it. So it doesn't matter whether that's positive or negative. I'm not going to screw it up.
Gotcha.
So when you're doing distance formula, do it the simplest way possible. In other words, the simplest way possible on the x's is 9 minus 1, right?
Mm-hmm.
And you don't care whether it's the same way on the other one or not. So you have 8 squared. What's the difference in the y's? That's all you need is the difference. How far apart are they on the number line?
So on the number line, it would be 15
3.
or
Here's the
3.
number line. There's minus 6. There's minus 9.
Oh, it's -9. Gotcha. Okay.
Okay?
Yeah, I
So
was looking at the
I don't
wrong
care
number.
whether this is a plus 3 or a minus 3. I'm going to square it. So it's going to end up being 9. So the distance is the square root of 73.
And I can't really simplify that anymore.
No, you cannot. That's a prime number. So you cannot simplify. You could turn it into a decimal, which would be an approximation. I'm assuming that at college level, they're not having you do that. They
Yeah, it
want,
says don't worry about it.
right, because this is the exact answer.
Mm-hmm.
Turn it into a decimal, you're no longer talking about the exact answer. You've rounded it off.
Gotcha. Next one I have is find the m or the midpoint of the line.
Okay.
So it says a equals -7 comma 2 and b equals -1 comma -8. So from what I remember, the midpoint formula is x1 plus x2 over 2, comma y1 plus y2 over 2.
Really easy. It's what's halfway between those two numbers?
So
And
between
you get the halfway
-7 and
point
1.
by adding them together and dividing by 2. You are correct. Your formula was absolutely correct. But
Okay.
conceptually, what's halfway between minus 1 and minus 7?
-4.
What's halfway between minus 8 and 2?
That would be -5.
Well, now let's look at that for a moment. How far away is 2 from negative 5?
It would be 7.
How far is negative 5 away from negative 8?
3.
That's not the answer then.
Okay.
Okay, now, if we want to follow a formula, add 2 to negative 8 and
Okay,
divide
so that
by
would be a -6 divided by 2, which is -3.
That's the way to do it. That's the
Okay.
formula way that will always give you the correct answer. But conceptually, it is halfway between those 2 points, always.
Okay. So the next one I have is x squared plus y minus 16 equals 0. And then it says find the y and x intercepts of the graph.
Okay,
So if I want to find the y, I would have to equal x to 0. And then if I wanted to find x, make y into 0.
perfect. So what's the y-intercept?
So it would be y minus 16 equals 0. So then I would add the 16, and then it would be y equals 16.
That's the y-intercept. Now tell me the x-intercept.
Then x would be x squared minus 16 equals 0. Then bring the 16 on the other side. Then would be x squared equals 16. And then square root of both sides. X is plus or minus 4.
Very good. I was sure you were gonna forget the plus or minus, but you didn't.
Nope, my teacher's been really harping on that.
I am too. I never fail to mention it to a student. It is
Uh-huh.
one of the most common mistakes in math. It really is. Uh, I'd say 80% of my students always forget it. And
Gotcha.
notice what we're looking at. That's a quadratic, right? That's
Mm-hmm.
y equals minus 16, or excuse me, minus x squared plus 16. Well, quadratic is a parabola. Now we know how to graph it because we know its vertex Actually, yeah, we know that that is the vertex because it's symmetrical about the y-axis. In other words, as long as that's -4 and that's +4, then we know the midway point is where the vertex is.
Gotcha. So I'm sending you a picture because this one I can't really explain.
Okay?
It's pretty much talking about like for each graph, select all the symmetries that apply.
Mm-hmm.
So I just emailed it to you just now.
Okay. Has it said file sent on your end yet?
1 second.
There it is. I got it.
You got it? Okay.
All right. So for every curve, they've given us 4 choices. So
Yep.
that thing let's talk about A. Is it symmetrical about the x-axis?
I'd say yes, since it splits it right in half. Or actually, no, I'd say more or less the y.
Well, if we were to take this thing and reflect it about the x-axis, would we not get that?
Yeah, that would be not the
That's not
same.
the same thing. So it's not symmetrical about the x-axis. Now, if we reflect it about the y-axis, we get that also.
Yeah, I agree.
Not symmetrical about the y-axis. How about the origin? Well, the origin you get by reflecting it about both axes. So if I do one reflection over the y, and now I do another reflection of that one, I get what I started with. So yes, it is symmetrical about the origin.
Okay.
And there's a couple other famous functions that are symmetrical about the origin. That one, which is y equals x cubed. In other
Okay.
words, if I reflect about the y and then about the x, I get that.
Gotcha.
Whereas a parabola is symmetrical about which axis?
The y-axis.
Correct, but not the x. It would have to look something like that for that to be symmetrical about it. Okay. So now on B. Symmetrical about x?
No.
Y?
No.
Origin?
I don't think so.
None of those. Number C. Symmetrical about x?
I'd say no.
Well, here's what we need to do to determine whether it's symmetrical about x. Is we need to take everything above the x-axis and reflect it
Okay.
over the x-axis.
So it looks the same.
Yeah, well, this is what you get when you reflect it over the x-axis.
Yeah.
And since that
So
is
it would
what
be
we started
symmetrical.
with, yes, it does have symmetry about the x-axis.
Okay.
About the y-axis.
I'd say yes.
Correct. And I gotta think that if it's symmetrical about both the x and the y, that it's
It's going to
always
be on the
symmetrical
origin.
about the origin. Yeah, because you get symmetry about the origin by reflecting over the x, which doesn't change it, and then reflecting over the y, which doesn't change it. So I'm going for all 3 on that
Okay.
one. Okay.
So the next one I have is like 2 different problems, but on the same scale.
And you
So
can
it'd be,
verbalize them.
yes.
Okay, go
So
ahead.
it'd be x equals y to the 4th minus y squared plus 3. And it's asking me like if it's symmetrical on the x-axis, y-axis, origin, or none of the above.
Okay.
And then the next one is 31x to the 4th plus 5y to the 4th. equals 5, and it's asking me about symmetry as well.
All right. Let's talk about odd and even functions.
Okay.
Because this is what we have to use to answer these two questions. An
Gotcha.
even function. An example of an even function is that. You have symmetry about the y-axis. And an even function is defined as f of minus x equals f of x. So everything
Okay.
in red there you need to understand. An odd function. An example of an odd function is a polynomial to an odd exponent.
Okay.
Notice the symmetry of an odd function is origin only. The definition
Gotcha.
algebraically is f of minus x is equal to minus f of x. Notice the difference.
Yeah, how the f of x is negative.
And that's the way that x cubed function looks. In other words, if I look at a value on the x curve, it equals y, but if I look at the negative value on the x curve, it equals negative y.
That makes sense.
Where it's opposite on the even function.
It's on even
Yeah, if
all
I go out
time.
there, I get a value there, and if I go the same distance there, I get the same exact value. So f of minus x is equal to f of x. And even is symmetry about the y-axis, odd is symmetry about the origin. Now, the clue on these problems are these numbers right here.
Okay.
They're all even.
Correct.
So when I substitute a negative for y, it doesn't change the function. In other words, negative y to the fourth power is the same as y to the fourth power. The same for
Sure.
y squared. Now, what I'm a little confused about here, I don't think it matters, and that's that they have x in terms of y. Well, any function can be any letter in terms of another letter. In other words, or is this within the framework of the xy coordinate system?
I think it might be the xy coordinate system.
All right, let's talk about that. You know that if you have y equals x squared, it's this kind of a parabola.
Correct.
But if you have x equals y squared, it's this kind of a parabola. The second one is not even a function. However, it does have symmetry. The first one, this one here, has symmetry about the y-axis. This one here has symmetry about the x-axis. Even though it's not a function, it's technically a relation, it still has symmetry about the x-axis. So the fact that they've chosen to call that x and these y, we're basically looking at a horizontal parabola.
Okay.
Now, you say, why is it a parabola? Because that's to the fourth power and that's to the second power. Well, I can think of this thing as being quadratic in nature. Quadratic in nature means that the first term is the square of the middle term. That's it. Well, that's what this is. We have a quadratic. That's a quartic in actuality, but it's going to graph like a quadratic. it's going to graph something like maybe this. Still going to have symmetry over the x-axis because that's to the fourth power, that's to the second power. In other
I
words,
see.
substituting minus y instead of y does not change anything. That's going to give you symmetry over the x-axis.
Gotcha.
Now, if we look at the other one, that's basically a circle. No, it's an ellipse. It's a funny looking ellipse. But you'll notice that if I were to let u equal x squared, then I would have 31u squared plus 5v squared. That's an ellipse. It's either a horizontal ellipse, and it is at the origin, or it could be a vertical ellipse. I don't know for sure at the moment. I'd have to do more math. But what is true about either of those in terms of symmetry?
They're all types of symmetry.
No, the horizontal ellipse is only symmetrical about what?
The y-axis
And the x-axis,
and the x-axis,
which
not the
means the
origin.
origin also. In other words, this one right here, certainly symmetrical about the x-axis. It is symmetrical about the y-axis. That means it's symmetrical about the origin. And this one here, same thing. As long as its center of that ellipse is at the origin, then it has all three symmetries.
That makes sense.
And that's all you have to know here. But it's the same concept, whether you're dealing with quartics or normally you're dealing with quadratics here. Or they'll give you something like this. Y equals x squared plus x plus 3. Okay? That's neither odd nor even. Because if you substitute minus x for x, this one remains at x squared. This one turns into minus x, and I still got that. And that answer is neither the positive or the negative of what I started with. So this kind of a function has neither even nor odd, which would mean it might not have any symmetry at all. But if a function is even, it has symmetry about the y-axis. If it is odd, it has symmetry about the origin. Now, they don't have a name for being symmetrical about the x-axis. In other words, this one down here, the reason they don't have a name for that is because that's not a function. Notice for a given value of x, I got two different values of y. That violates the definition of a function, does not pass the vertical line test. So they don't have a name for that. They have a name for even functions because they are functions. They have a name for odd functions because they are functions. They don't have a name for symmetry about the x-axis. It's not a function.
Oh, and the vertical line test means you can only go through one point.
What's that, Taylor?
The vertical line test means it can only go through one point.
Yes. Whereas this bottom picture right there, my vertical line goes through 2 points.
So it doesn't work on the y-axis.
Just not a function.
Okay.
It's still a very important shape and a figure in mathematics. You do get to a point in mathematics where you move beyond functions, where it's not that important if something is a function or not. But in terms of names, when we have even and odd, and when we're looking, well, you still have symmetry about the x-axis. It just doesn't have a name like even or odd. But the fact that it's of the format x equals y squared instead of y equal x squared means that it is a horizontal thing that looks a little like a parabola. I kind of meant to draw it like this. I think the way that thing actually looks is something like that. But regardless, it has symmetry about the x-axis.
Okay.
when you graph a quartic. Taylor,
Oh,
sorry,
thank you for
I've
the
taken
help,
you
Mr.
over
Callan.
your half hour. Have any last questions? I assume you have a final coming up soon?
Oh, I just got a test day after tomorrow that I'm just doing practice stuff for, and I just wanted to ask you a few questions.
Okay. Well, I got some time between now and tomorrow if you need additional help.
Okay, sounds good. Thank you for your help.
All right, you're welcome. Talk to you later.
Alrighty, sounds good.